Welcome, ladies and gentlemen, to your MN9, where we're going to use segments and congruence. This is section 1.2 in your textbook. We're going to first define what a postulate and a theorem is before we get into the section examples. A postulate is a rule that is accepted without proof. It's a rule that is accepted without proof. Sometimes I tend to think of a postulate as kind of the common sense approach, where, for instance, if it's raining outside, we can say, it is raining outside. We don't need to prove that it's raining outside. You can look and see. You don't actually have to go outside to decide that. A postulate is very much an accepted idea without feeling like you need to prove it. A theorem, on the other hand, is a true statement that follows as a result of other true statements, essentially proof. You need to prove it. So a theorem is a true statement that has been proven using other true statements. And this is kind of a big idea. The idea of a theorem, or what I tend to think of when I hear theorem, is if, for instance, you have a lawyer in front of a judge and they're trying very hard to show proof that their client is innocent, they would use proof. They would have to prove using very evidence or other true statements to prove that in fact their client is not guilty. You can't just say, like a postulate, my client is guilty, and assume that that's going to go. A theorem, you have to prove it very logically with very clear definitions. So theorem needs to be proven. Postulate is just a rule that we accept without proof. So down here, the first thing we're going to talk about is the segment addition postulate. And since it is a postulate, this is again a rule that we just accept. And let me kind of tell you what this rule is. It says if B is between A and C, then, well, before I say then anything, let's go down here on the line and put a point B. Actually, B is between A and C. So we're going to put point A and point C, and we're going to put B somewhere in between there. Doesn't matter where. I'm trying not to make it look equal. That's the first thing I'm going to say. And here's what this postulate addition, the segment addition postulate states. It says that if you take this segment, AB, and I'm going to write it up here. So if you take AB and add it to segment BC, so if you take the blue line segment and add it to the green line segment, well, we know then that what you get is this full length, which in this case is AC. So let me say again, segment addition postulate is literally taking pieces of a segment, so AB segment plus BC segment, and that in turn would give you the full length of AC. Now that is a very general look at what the segment addition postulate states. So let's do an example down here. It says point G is somewhere between F and H. So I'm going to put F here and H here. So drawing a picture really helps here. Put point G somewhere in there. Doesn't matter. We're just doing this again, not for any more than giving us information so we can kind of see what's happening. So it says FH is 22 units. So F is right here, H is right here. This length from F to H is 22 units. And it's also saying that FG, and I'm going to switch colors here, FG from here to here is 5 units. They want us to find GH. So they're trying to have us find this length right here. This is the big question mark, right? So you can look at it and just use number sense. And really, if you look at it closely, obviously 5 plus some number gives you 22. So you can take 22, subtract 5 from it, and that will give us our length that we're interested in. And in this case, it would equal 17. So we're just trying, now I'm looking at my picture, and clearly I'm not drawing it to scale or any other thing for that matter. But again, what we've just found is that this length is 17, because 17 plus that 5 is equal to 22. So I'm going to say my line segment GH equals 17. That is my answer. Down here, it's there's a reminder, and just again taking a step back, all we've talked about is segment addition postulate. We're now going to talk a little bit about congruence. First thing I need to remind you, though, and we've talked about it in the past, that the symbol for congruent is an equal symbol with a squiggly line above it. And again, just to make sure you remember, a squiggly line means similar, and this, of course, means equal. And two squiggly lines means approximate. And people get those confused a little bit, so I just want to make sure that you have them somewhere on your note guides to reference back to if you do forget. Example 2 here, it says plot these points and determine whether line segments MA is equal to TH. So I want to know if this line segment is going to be congruent to this line segment. And the easiest way to start with here is to graph it. And luckily I have a graph right here, although it looks kind of cut off. Hopefully it's big enough. -4, 1, 2, 3, 4 is right here. 2, 4, 1, 2, 1, 2, 3, 4 is right here. So this point is M, this point is A, this segment is MA. Then we have 1, 4, and I'm going to do this in a different color. 1, 4, 1, 1, 2, 3, 4 is right here. This point is T, and 1, -2 is H. And when you connect them, this is what you get. So let's count or find the length, because really what we're trying to do is find out if they're congruent, and if they're congruent, that means they have the same length. So this B one, the blue one, this MA, the length of it is 1, 2, 3, 4, 5, 6 units. Let me count that again. So I have 1, 2, 3, 5, 6 units. My TH is 1, 2, 3, 4, 5, 6 units as well. So since they are the same length or the same distance, we can conclude that these two line segments are congruent. And this is how we want to write it. We want to say that MA is congruent to TH. If it weren't congruent, we would write the same exact thing, but we would put a line through like this. But we don't want to do that, which, by the way, that would mean non-congruent. We don't want to do that because in this case, they are congruent. Okay, well, thank you for tuning in, where we were talking about segments and congruence.